Hello everybody. I received some inquiry about question 3 in the assignment. Okay, it's three equations, differential equations, and you want to solve them using matrices. Okay, now I will explain this equation, this problem here, which have two equations, differential equations with two variables. My variables are x1 and x2. As you can see here in this equation, equation number 1, equation number 2. Okay, now I will build the matrix presentation, which means that here the A matrix 1 and 3, I put them here 1 and 3, and 2 and 2, I put them 2 and 2. What I built here? A matrix. Let's assume we have extra equation, it means 3 equations similar to the assignment. What will happen? The matrix here, rather than it become 2 by 2, it will be 3 by 3. Just add extra items. Very simple. Now, also here, you can see here, I have two unknowns. If they are 3 equations, I have third unknown. Also very simple. Now, you can see here, x is x1, x2. If there is third equations, it will be 3 here. And for x dash, it will be x3 dash, and the condition initial will be increased also. Okay, now how we solve them? It's a procedure you follow, regardless if there are 2 equations, 3 equations, 4, more, less. You follow the procedure. First of all, you find the eigenvalues. You find lambda, as we discussed, and we solve many problems in the lecture. Minus lambda I equals 0. We solve it to find lambda 1 and lambda 2, as we discussed. For each of these lambda, we solve also to find p1 and p2, the eigenvectors. We solve many problems. Okay, in lecture and in tutorial. Now I solve this matrix A here to find eigenvalue 4 and minus 1, and their eigenvector 1, 1, 3, minus 2. Very simple. Now I put them side to side, as you can see here, to construct my matrix, which is Q. Now this Q, if I find its inverse and multiplied by A and by Q again, I will go matrix D. What matrix D represent? It's a diagonal matrix which have eigenvalues in its diagonal as elements. You see 4 and minus 1. Now next, I will solve to find x. Have a look. We said in the theorem, in the lecture, that x equal qy. This is x, this is y, and this is q. We constructed. So multiply this row by this column, we have equation. This row by this column, we have equation. Oh, this is x and y, x1 and x2. What is needed here to find x1 and 2? I need just y1 and y2. How can I find them? We have formula say y dash equal dy, and we already have D, the diagonal matrix, this one, which make my task very easy because it's diagonal matrix, all items 0 excluding 1. So you see, I multiply this row by this column, I got equation. This row by this column, I got another equation. Solve them. As example, this one, if I come to solve it, I will say dy1 over dt equal 4y1. Cross multiply and rearrange, it will be 1 over y1 dy1 equal 4 dt. If I integrate both, I will have ln y1 equal 4t plus c, definitely the arbitrary constant. If I take exponential, then it will be simplified more. It will be y1 equals c1 exponential 40. I did the same for the second one here. So what I got y1 and y2. Just substitute here and here, as you can see. Then multiply row by column, you have equation. Multiply row by column, you have equation. Okay, I got the equations. You have 2 constants. If you are given initial condition and you already given initial condition, just substitute and find these initial these constants C1 and C2. Now what is the difference if I have three equations? Just expand the matrix. It's very easy. If we have four equations, 4 by 4 matrix A, and the procedure we keep the same procedure. I want to stop here. Good luck.